$33.3 billion. That is the estimated size of a gas-fired power project announced under the Japan U.S. Strategic Investment Initiative to supply electricity to AI data centers and other large loads in the United States. At roughly 5.2 trillion yen, the number is larger than many headline chip investments. It also changes the frame. The AI race is no longer only about processors, models, or cloud contracts. It is becoming a contest over turbines, substations, transmission access, fuel, construction schedules, and who carries the risk if expected demand arrives late. This video follows the money behind that shift. The announcement is not a single data center, and it is not a completed power plant. It is a first-wave strategic investment project whose details still require coordination. The public description names a gas power project for AI data centers, with Japanese industrial groups interested in supplying equipment. That distinction matters. $33 billion is an expected total project amount, not a final audited cost. The investment stack can include generation equipment, engineering, construction, grid connection, fuel infrastructure, financing, and supporting components. So the useful question is not whether one giant check has been written. It is which suppliers, contracts, and milestones can convert a political announcement into dependable megawatts. AI campuses combine three characteristics utilities rarely see together: enormous scale, fast proposed timelines, and a strong preference for continuous operation. A campus may ramp in phases, but every phase needs firm capacity, backup systems, and a credible connection path. Software teams can order servers faster than utilities can build a new transmission line. That mismatch pulls power investment forward. Developers want capacity reserved before every building is complete. Utilities want evidence that the load will actually arrive. Regulators want ordinary customers protected from speculative upgrades. The result is a new contract market around deposits, minimum bills, construction security, and exit fees, financial tools designed to make demand credible. A data center campus and a power system run on different construction clocks. Buildings and server halls can move from site work to operation in a few years. Major transmission projects, substations, turbines, and specialized electrical equipment often require longer studies, permits, factories, and commissioning. Even when the generation site is clear, the project still needs a path through the grid and a plan for reliability. This is why an announcement measured in dollars should also be read as a schedule. The key milestones are not press release, groundbreaking, and ribbon cutting. They are interconnection study, equipment order, financing close, fuel arrangement, energization, and the date each block of firm capacity becomes available. Think of the project as a layered ledger. First comes the generating plant: turbines, heat recovery systems, generators, controls, and civil works. Next comes the grid connection: switchgear, transformers, substations, and transmission upgrades. Then comes resilience: backup equipment, redundancy, spare parts, and operating reserves. Fuel supply adds pipelines, transport contracts, or storage. Finance adds interest during construction, guarantees, and contingency. Finally, data center delivery may require dedicated on-site infrastructure. The point is not that every dollar is known today. The point is that AI power is a portfolio of industrial systems. A turbine maker may capture value even when a model provider does not. The most important clause may be the one that explains what happens if the customer changes its mind. FERC 2026 action on large load integration emphasized speed, transparency, and preventing unfair cost shifting. That is the heart of the issue. If a utility builds a substation or generation asset for one enormous customer, who pays when the load is delayed, downsized, or canceled? Strong agreements can require deposits, credit support, minimum payments, and exit charges. They can also define when capacity becomes firm and what interruptions are allowed. The real investment case therefore lies in the contract, not only in the engineering drawing. Gas generation can provide dispatchable power on a timeline that may look attractive beside slower infrastructure options. It can support continuous loads and balance variable renewable generation, but it does not eliminate risk. It introduces fuel price exposure, pipeline constraints, emissions rules, water and cooling needs, and possible future retrofit costs. A project designed for decades must survive more than the first data center lease. The commercial question is whether its contracts allocate fuel, carbon, and utilization risk clearly. The policy question is whether new supply expands the system or simply competes for constrained infrastructure. Firm power has value, but the value depends on location, hour, and contract. The public announcement points toward a wider supplier ecosystem. Large electrical manufacturers, turbine and control system providers, construction firms, metal fabricators, and smaller component makers can all participate. That is the channel's core distinction. Follow the infrastructure ledger rather than only the famous AI brands. The biggest winners may be companies that solve a physical bottleneck, high-voltage equipment, protective relays, cooling, transformers, and grid studies. But a supplier name in an expression of interest is not a booked order. Investors should separate interest, memorandum, signed contract, backlog, delivery, and recognized revenue. Each step has a different probability and a different timeline. Use 5 questions on every giant AI energy announcement. 1. Is the dollar figure committed capital, expected total cost, or a policy target? 2. What exact capacity is being built and when does each phase energize? 3. Which equipment has been ordered and which permits are still open? 4. Who pays for grid upgrades and cancellation risk? 5. What fuel, emissions, and reliability assumptions support the economics? If those answers are missing, the headline is a direction of travel, not a bankable model. The announcement can still matter. It reveals where governments and suppliers expect constraints, but disciplined analysis separates strategic intent from executable cash flow. The $33 billion power project is important because it exposes the industrial floor beneath artificial intelligence. Models run on chips. Chips run in facilities. Facilities run on power systems built from steel, copper, transformers, turbines, software, labor, permits, and contracts. That chain creates opportunity far beyond the most visible technology companies, but it also creates schedule and financing risk. The next time an AI campus is announced, do not stop at the number of GPUs. Ask what must be built before the first rack can stay online, who earns revenue at each milestone, and who pays if the expected load never arrives. That is where technology meets the ledger.